Okay, this is a brief introduction to stacks in C++. I'm only going to talk about the stacks that are part of the standard template library. I'm not writing our own stack, and I'm going to use this program challenge to do so. It's a program challenge that is going to test if a string is balanced as far as whether it has a correct number of open and closed parentheses. And everything's given to us except for the function is balanced. We have a prototype for it, but we don't have the function definition. I'm going to copy the prototype, make it into the header. We know it's got to return true or false because the return type is a bool, so we'll put that code in there. And we'll comment out return false to just make it always return true while we're testing. And eventually we know that under certain circumstances it will return true and others it will return false. So how do we use a STL-based stack? Let's just copy and paste on the PowerPoint presentation. It is a template-based class, so we can tell it what kind of data we want to be stored in the stack. In this case, we're going to do characters, which works well for this program. And we're not going to store just any old characters. We're only going to use the stack to store parentheses. You see, once we create our paren stack, we have all these methods, properties that are available to us, one of which is push. So we don't have to write the code for push. We can just take advantage of code that is already written. And to test this, let's just try to push the first character in the string. Now remember, C++ treats strings as if they were arrays of characters, so we can use the subscript operator on the string, and we're going to push that as a character into the stack. And just for some feedback, I'm going to output to the console when I do a push. And I should also test if you can do a pop, so I'll add that on our built-in methods. And you see with IntelliSense that pop does not need any kind of parameters, so we're not going to send any arguments. We're just going to do a plain old pop, and then see out that we have popped just to give some feedback. This isn't addressing the specifications of the program yet. We're just making sure that we can make a stack and that the basics of the program is working. It's always going to return true, so it should always say the string has balanced right now. I'm going to put in any kind of input, and I see that it did push and it did pop, so I'm on the right track. But I'm not sure exactly that the stack got anything. We just know that it didn't cause an error. We can see the size of the stack with the size property, size method. So I can output the size before I do a push, after I do a push, and after I do a pop to test that I am actually adding to the stack and then popping off the stack. When we do try to solve the problem, this will be a useful method for us to use, because we're going to have to find out at the end of the program if there still is anything in the stack. We'll be able to do that by using the size. And we'll clean up this user interface to say size before push, size after push, and size after pop. I'll run it again with any kind of input. And if it all worked out well, we should see 0, 1, and 0, and we do. Formatting isn't the best, so let's clean that up real quick. And then we'll take a look at the actual problem itself. The way the program is supposed to work is we're going to take a sentence and compare if the open and closed parentheses match up properly. And the way we're going to do that is by reading in each character, and we don't have to do anything with the stack if it's not a parentheses, an open or a closed. But when we reach an open, we're going to push it onto the stack. We're going to continue reading through the string, so we're going to use a loop for that. When we get to a closed parentheses, we're going to pop off of the stack. And we continue doing that for the rest of the sentence. And then we continue reading the string, getting to another open parentheses. And yet another open parentheses, so we continue pushing. It's a first in, last out structure, so we're going to draw this on the top. And we get to another closed parentheses. And we're going to top off the top. The last one in is the first one out. That one goes away. We continue reading. We get to another closed paren. Pop off this bottom one again. And this would be a properly balanced sentence. But we need our program to handle other circumstances as well. Like if there are more opens than closed. If there's an open, we push it onto this onto the stack. Now we've got it closed. We don't push it onto the stack, but we would try to pop it, and if we popped, it would be empty, and that would cause an error. So those are the special circumstances we have to look for. If we are looking at the sentence and there still is something in the stack, we know that there were too many opens. If we reach a closed paren, we would try to pop and there'd be nothing there. So we know that that's a problem. So I'm going to just do a quick test of reading and looking at one character and only doing the push if the character is an open parentheses. Remember, C++ treats strings as arrays of characters. So I'm just going to look at that first element, see if it's equal to the character open parentheses, use a single quote there, and if it is, then I'm going to push that character. Eventually, you want to make a for loop here to start out at 0, and as long as your subscript is less than the length of the string, there's a built-in method to get the length of the string, then you want to keep on checking it to see if it's equal and then incrementing your subscript. So this should, if I put in just text, it'll never do a push and it'll try to do a pop. When it tries to do a pop, when there's nothing in the stack, it gives you an error just like that. But here, if I do an open paren, it should push and that should not give an error. But it still says true, so you got to finish adding that functionality.